All right, let's take a look at an introduction to electrical charge. What is electrical charge? Well, we're going to find out that's the basis of current flow. So in electrical charge, we first off understand that within our atoms, we have an electronic charge and we have a proton charge, a negative charge and a positive charge. And in every case, the electronic charge equals the proton charge. Negative charge equals the positive charge, okay, when things are balanced. So charge, we give it the letter Q, capital Q, is a fundamental characteristic of electrons and protons. So if we look at it diagrammatically here, diagrammatically we have two gray subatomic particles, okay, or charges. Uncharged, all grayed out, no force. There's no attraction, there's no repulsion, there's nothing going on here to upset the balance. But if we give an equal and opposite charge on each side, positive on the left, negative on the right, we have opposite charges, they will be drawn to each other. If we have both of the particles charged positive, they will repel each other. Likewise, if we give them both negative charges, they will repel each other. So unlike attract, like repel. So if we look at this again diagrammatically, how can we show what's going on here? Well, we can create what are called lines of force between fields being positively and negatively charged. The electric field then formed by these lines of force then shows a oppositely charged surface, one being drawn to the other. Since this course deals with us characterizing all of these values and all of these fundamental units mathematically, we need to assign values to them. So we're going to look at the electrical charge. That electrical charge, we're going to be giving it the name of the Coulomb, which is the unit of charge. So the electrical charge, Q, capital Q, is measured then in units that we call coulombs. We're not going to spell that out every time, so we're going to give it the symbol of capital C. So to look at 1 unit charge, 1 coulomb, the total charge then is 6.25 times 10 to the 18th. That's 6.25 with 18 zeros, okay? It's that many electrons. So 1 coulomb is a heck of a lot of electrons of charge. Okay, typically we're not going to see large charge values. We're going to see very small charge values. So we have to do something with the exponent here. Well, in doing so, what we need to do is create our relationship that the electrical charge Q is equal to the number of electrons that we are interested in, and we are going to divide it by that number, the 1 coulomb. So we're looking at normalizing things. So 6.25 times 10 to the 18 electrons per coulomb divided into the number of electrons of interest will give us the charge. So if we're looking at just what's the charge of 1 electron then, 1 in the numerator divided by 6.25 times 10 to the 18th. If we take 6.25 times 10 to the 18th and invert that into the numerator or divide it into the number 1, we get a value of 1.6 times 10 to the minus 19th coulombs. So 1 single electron has a very, very small charge. So that's 19 zeros going to the left now. Okay, so there's our unit of Coulomb and charge. So in looking at what goes on here with positive and negative charges here, so we're going to look at a hydrogen atom and a chloride atom. And why we chose these? Well, hydrogen chloride is a very common element, or not an element. Each of these is an element, but a very common combination of 2 elements, hydrogen chloride. The neutral hydrogen atom then has a single valence electron. So we saw that before. 1 proton, 1 electron. It is very, very neutral compared to the chloride atom. Let's look at the chloride atom. the chloride atom has 17 protons and 17 electrons. So what we're looking at here is some way of combining these two atoms to form a new substance that we call hydrogen chloride. And what will happen is that valence electron in the hydrogen atom is going to jump into the outer or valence orbit of the chloride atom. Okay, so when we do that, now we have combined the two. They've connected together in that valence electron to form a gas that we call hydrogen chloride. Okay, so with those two being very susceptible to each other, you can see how we form other compounds with individual elements. Okay, so when we do that, then you'll notice that the electron now has clearly embedded itself into the chloride ion. So now we have a positive hydrogen ion, one proton, no electrons. So it's now become more positively charged. Over here, we have a negative chloride ion because it has taken on an additional electron, which gives it a negative ion status. 17 protons, 18 electrons. So now when we dissolve in water, hydrogen chloride gas will separate into positive hydrogen ions and negative chloride atoms. That's just a reaction that occurs once it hits water. Okay, so let's look at some of those mathematical relationships. If we take a look at this example, how many coulombs do 93.8 times 10 to the 16th electrons represent? So that's a lot of electrons. So we put it into our relationship. We are going to take 93.8 times 10 to the 16th electrons. We're going to divide it by 6.25 times 10 to the 18th electrons per Coulomb. Okay, so notice we have electrons in the numerator, electrons in the denominator, and those two values are going to cancel out, those two units, and what we're going to be left with then is just charge. So when we do the division, divide 6.25 times 18 into 93.8 times 10 to the 16th on your calculator, and we get 15 times 10 to the minus 2 coulombs. Okay? If we want to put it into decimal form, it becomes 0.15 coulombs. Okay? Very, very small unit of charge. Another example. How many electrons does it take to have 3 coulombs of charge? So we're going to move this relationship around. So we start with the relationship that Q is equal to the number of electrons divided by 6.25 times 10 to the 18th electrons per Coulomb. The number of electrons then by itself, once we move the value in the numerator on the right side to the left side, becomes Q times 6.25 times 10 to the 18th electrons per Coulomb. We know that we were asked how many there were in 3 coulombs of charge. So we're going to substitute for Q 3 coulombs. So 3 coulombs times 6.25 times 10 to the 18th electrons per Coulomb. Now this time the Coulomb value, C, is what's going to cancel out. And what we're going to be left with is the number of electrons. 1.88 times 10 to the 19th electrons. So now we got pretty good amount of electrons that we're dealing with in this related problem. Okay, so we've taken a look at electrical charge. We defined the symbol for charge. We've looked at the unit of charge and what its unit symbol is, what causes positive and negative charges, those electrons jumping off the valence, and how much charge in coulombs is there. So we look one more example. How much charge in coulombs is there in 10 times 10 to the 12th electrons? Again, we just take our value, stick it in the numerator, 10 times 10 to the 12th electrons divided by 6.25 times 10 to the 18th electrons per Coulomb. Run that through your calculator. You get 1.6 times 10 to the minus 6. Okay, we're going to start using these metric values. 10 to the minus 6 is a micro, so we're going to call it 1.6 microcoulombs. Okay, fairly small number. Okay, so in the next section 3, we're going to start looking at voltage and defining what the unit of voltage and its characteristics are all about.